Hello, everyone. In this video, we are going to begin with the preliminary example in section 4.4 on the fundamental theorem of calculus. So far in this first couple of weeks of our class, we've been talking about how we can find an accumulation of a quantity based on the rate of change function of that quantity. In this section, we're going to start to really make that precise, including learning more about the integral. So let's get started on this preliminary example. So we have that a small plane starts out at the end of a runway and accelerates towards takeoff. Let S of t represent the position of the plane in meters relative to its starting point after t seconds, and let V of t represent the velocity of the plane in meters per second after t seconds. Our job is to write down two expressions that represent the change of position of the plane between time t equals a and t equals b seconds. So what I'd like you to do right now is to pause the video and think about this question and see if you can come up with two expressions on your own first. And then when you're ready, go ahead and continue the video. All right, so let's chat about this problem together. So we're given two different functions in this preliminary example, though they are related. So what are those functions? We have S of t, position, and V of t, which is velocity, or the rate of change of position. So let's just begin by thinking about this position function, S of t. So S of t tells us what? It tells us our position after t seconds, so it tells us how many meters we've traveled, or how many meters we are located. We'll say that instead. Meter location at t. So if we want to know the change of meters that we've traveled from A to B, then if we calculate our meters at B, S of t, subtract however many meters we were at A, S of A, we're going to compute the total meters traveled from time A to B. So can we also come up with this measurement, the meters traveled from A to B, using the velocity function? Well, what we've seen in our class so far is that we can compute an accumulation of quantity, so meters in this case, by looking at the integral, or the area, under the velocity curve. So here's our rate of change function, V of t. So then the area from A to B under our curve is also going to tell us the number of meters traveled from A to B, from time t equals A to B. So let's write that down. So the velocity, that's the rate of change of meters. So using velocity, we can compute the integral from A to B, V of t, with respect to t. So this value, the area under the velocity curve from A to B, also gives us total meters traveled from A to B. So we just came up with two expressions for the same thing. So that means these two expressions are equal. Whoa. Those are exclamation points. This is exactly what the fundamental theorem of calculus will be telling us. And we're going to make that a little formal in this next box. So please feel free to rewatch any parts of this video and meet me for the next one, where we talk about our definition, our theorems, total change theorem, and fundamental theorem of calculus.